Hello and welcome to Physical Sciences. Today our focus is on the classification of matter. My name is Themba Ncube. By now we probably familiar with that anything that exists around us is actually a form of matter. Put simple, we know that matter is everything, and everything around us, physical or otherwise, is a form of matter. Without any waste of time, let's look at the big ideas that have to do with matter in terms of the concept map, or some of the very important aspects that relate to matter. Right. Okay, so we talk about the composition of matter. So matter is actually the big idea. So if we talk about the composition of matter, we actually asking ourselves, what is it exactly that makes up matter? And we also know that by now that matter consists of pure substances, okay, pure substances that are actually divided into two broad categories, which are elements and compounds. We look at each one of them in more detail as we go along. But our major focus today is also to look at the physical properties of matter, which determines exactly why we use certain types of materials for specific purposes. Also, ultimately, we'll look at the various types of mixtures, which is the homogeneous as well as the heterogeneous, and how these exactly differ from what we would refer to as pure substances. Right. Okay. Now, the thinking activity is something that's going to guide us. So there are two broad questions that we would want to put out there, So by the end of this session, we must be able to arrive at some form of understanding in terms of responding to these, big questions or big ideas. So we must think along the lines of saying, okay, have you ever thought about what properties of matter, okay, influence the choice for their use? So we want to relate use of a particular type of matter or material, based on its physical properties, or the type of properties that a specific form of matter actually has. And then the second question centers around the idea of why matter exists in different forms. Okay, so these are the big ideas. We're not going to go further into detail, but the discussions that we're gonna have would most certainly, in more ways than one, try and address these big questions. All right. Okay. Now the terminology. There are some keywords that we'll definitely use once too often than others. We need to also understand their meaning in the correct scientific context. Okay, so the terms like classification would say we are classifying matter either into pure or impure substances, mixtures, into homogeneous as well as, heterogeneous. So classification, in other words, we can say we are categorizing different forms of matter that will be given to us. Right. So we'll talk about classification. Now we also talk about matter because this big topic is about matter. So matter is everything that has got mass and volume. And in other words, matter does occupy space. So we talk about matter in the context of everything. Okay. So everything around us is matter as long as it occupies space and it has got mass. So material will be used interchangeable to refer to matter. So, matter is a broad term, and then material becomes specific to a certain type of matter. Right. Okay. Now, under classification of matter, let's understand that matter is quite a broad, term. Okay, but we can further break it down, into simple terms and say, okay, if we have a given type of matter, we can classify it into two broad categories. Now, what are these categories? We've got pure substances as well as impure substances. So, given any form of matter, it can either be a pure substance or an impure substances. But then how then do we get to say, okay, matter X or material X is actually one of the two categories? It's based on the properties that we shall discuss further in detail. Right. Okay. Okay. Now, the other keyword that we will meet once too often or use quite a lot in our discussion for this session is pure substance. So a pure substance is a form of matter, okay? So let's think of it as a form of matter, okay, which falls into one of those two categories. And then this is a form of matter, right? So a pure substance is a form of matter, okay? And pure substances are either divided into elements or compounds, okay? So in short, what we are simply saying, if you've got a pure substance, two things can happen. A pure substance, whatever it is, it can either be an element or a compound. I think even from our, our earlier interaction with matter and materials, because this broad topic is not entirely new to us. At some point or the other, we spoke about, the term element in terms of, the periodic table of elements, which is something that we shall also try and look into more into detail as we go along. And then again, we spoke about compounds, which is made up of elements. So elements and compounds are forms of matter which are classified under the broad category of pure substances. Okay, so we'll use these key terms quite a lot, right? And then matter is pure substances, okay, or impure substances. And then under pure substances, we can either have a substance being an element or a substance being a compound. So both elements and compounds are actually pure substances. So we can say elements and compounds. This is what this is a conclusion that we are actually arriving at, are pure substances, okay? That's a fact, okay? So elements and compounds are actually pure substances, okay? And pure substances are actually a form of matter, which is one of the two broad categories, okay? So now, when we talk of impure substances substances that can be mixtures, okay? Mixtures are further divided again into either homogeneous or heterogeneous. So the word homo actually means uniform, while hetero means, non-uniform, okay? So impure substances are actually mixtures. So in short, we can also say mixtures are impure substances, okay? So the main idea here is to try and classify, okay, or categorize. So we're saying that pure substances are either elements or compounds, and then impure substances are actually are mixtures, and mixtures are further divided into two categories, okay? Right. We will also look at individual properties of each one of those. So this is the big idea in terms of classifying matter in general. Right. Now, let's look at mixtures, okay? The word mix in itself, it says a lot in terms of having a lot of components coming together, So it's more than one type of a substance within the same space. It could be a container, it could be anything. And ideally, there are real life or everyday life examples that we'll use to try and bring an understanding of what exactly a mixture is and what is it that separates a mixture from other pure substances, which are actually elements and compounds. But there are also differences and similarities that we need to pay careful attention to in as far as classification is concerned. Right. So we are saying that a mixture forms when two or more, okay? So it's more than one substance, okay? They are combined. It could be in the same container and mixed physically, that's the key word, okay? Without them chemically bonding. So in a mixture, typically what you have, you've got more than one substance. It could be any number of them. And then these two or more substances are actually put within the same container. They don't chemically bond with each other. They retain their properties. So that's a mixture. So a mixture is actually made up of pure substances that are not chemically bonded to each other. That's the main idea that I think we definitely need to point out. Right. Okay. So that's as far as a mixture. So what are some of the properties of a mixture? Now, the moment we start talking about properties of a material or of a type of matter, we are definitely going to look at each one of them, and then these properties would determine whether that mixture is either, a homogeneous mixture or a heterogeneous mixture, or largely whether that substances or that material that is given to us is either, a pure or impure substance. But generally, all of them are just described or are referred to as matter. So properties are going to assist us in terms of classification as well. Okay, so in a mixture, components are not in fixed ratios. Okay, what that simply means is that we don't have to have a fixed amount of each of the individual substances that come together in a mixture. It can be in any ratio. You can have 2 parts of substance A and 10. In the other case, you can have 5 parts is to 3. It doesn't matter. That's what exactly it exactly means when we're saying that these are not in fixed ratios. Okay, that's a very important property or a characteristic of a mixture. And again, these individual components that make up a mixture, they still keep their properties. Hence, we say they retain their properties. So if substance A in a mixture of A and B are together, it's still substance A. If it was sugar, it will still taste sweet. If it was, something that is sour, it will taste sour, even if it's in a mixture. Why is it so? Because these substances did not chemically bond with each other to actually form new substances. As a result, they actually retain their individual properties within a mixture, right? Okay, and then thirdly, it says here, components can be separated by using physical techniques, okay? Now, the point that we're trying to make here is that within a mixture is reversible. And at some point, we are able to say, okay, we want to extract substance A from a mixture of A and B. Okay, so mixtures are actually reversible. We can actually separate the individual components that actually make up that mixture. So mixtures are not permanent. But also bear in mind, that is only possible because of the fact that these substances did not chemically bond with each other to form other substances, making it irreversible. So mixtures can be separated by using physical techniques, right? And then in terms of the 2 categories of mixtures, we've got homogeneous as well as heterogeneous mixtures. The word homo means uniform, okay? So the word homo suggests that the mixture is uniform. We'll talk to that in more detail in terms of what exactly it means. It's uniform in what respect, okay? Hetero means non-uniform, okay? So those are our catchwords, right? So a uniform mixture is a homogeneous one, while a non-uniform mixture is a heterogeneous mixture. And a mixture is actually an impure form of matter, okay? So these are impure substances or materials, okay? We can think of it that way, right? And then in terms of the homogeneous mixture, we have identified that what stands out about a homogeneous mixture is that the composition is uniform, okay? We'll talk about that. So when components of a homogeneous mixture cannot be distinguished from each other, they're actually in the same phase. Most solution, as a practical example, if you take your water and your sugar, of which the sugar is completely soluble in water, it forms a homogeneous mixture. So that's a uniform mixture. And now within that solution, we are not able, or we are not in a position to say, okay, these are the sugar particles that make up the sugar, and then these are the water particles that make up, or the water molecules. So if we cannot distinguish between the components that make up that mixture, then that particular mixture is actually a homogeneous mixture. Okay, straightforward. And then there is a typical example that we spoke to with respect to a solution. So most solutions are actually homogeneous mixtures, right? Okay. Now let's talk about another practical example of a homogeneous mixture. We know that air is actually a mixture of gases. What that simply means, because the word air is usually used to actually refer, to any gas, would say it's air. But air, in essence, it's actually a combination or a mixture of different substances, okay? But these substances, what is actually common about them is that they are in the same gaseous state, hence would refer to it as a homogeneous mixture, because we cannot separate, the nitrogen molecules from the chlorine, from the argon, the oxygen, the carbon dioxide. The list goes on. So as a result of that, based on those properties, we can actually say that, yes, indeed, air is a typical example of a homogeneous mixture. Okay, right. So if you look at the pie chart there, it talks about, the proportions of each of the individual substances that actually make up that mixture. 78%, nitrogen, 21, and also there's another combination of many gases which makes up 1% of air as an example. And then we also have alloys. Alloys are, are mixtures of metal, okay? And alloys are actually also practical examples of, homogeneous mixtures, because it's just a solid material. But that particular material is made up of a combination of different metals, okay? Now, you have got, brass, which is actually made of copper and zinc, bronze, which is made up of copper and tin, stainless steel, which is made up of iron and carbon. But also, bear in mind, the alloys actually are the main reason why we have alloys. It's based on the, physical properties. On its own, copper, as an example, is a corrosion-resistant type of metal. But then for a particular purpose, you need a corrosion-resistant, and then you also need maybe a stronger metal. So a combination of the two will give you both properties, which is ideal or fit for that purpose. So that's the reason why there is a wide range of application in terms of the mixtures, which says then there is a need for us to actually understand. And then the second category of mixtures is based on the heterogeneous mixtures. Okay, we have said the word hetero means non-uniform. So a mixture that has got a non-uniform composition is typically a heterogeneous mixture. Okay, so what's so special about, or what distinguishes a heterogeneous mixture from the other mixture which is uniform, is that the components that make up these heterogeneous mixtures, they are not in the same phase. And as a result, we can easily distinguish the individual components that make up a heterogeneous mixture, right? Okay. Now, having said that, you can have, look at, the example there that's given, which is, I think it's oil that has low density, it's floating on water, and as a result of that, we can actually distinguish between these two components that make up that mixture, right? Okay. So examples of, heterogeneous mixtures as we know them in real life. We've got emulsions. So an emulsion is actually a mixture which is obtained when one liquid is shaken up with another one and they do not dissolve completely, okay? E.g., for example, we have salad dressing. In salad dressing, we've got different liquids. Now, even if you shake it, those two, they'll mix, but at some point, they'll be separated. One will either be floating, with some, suspensions in terms of, solid components within that mixture. So these are typical or common, everyday type of mixtures that would want to make, reference to. And then also we've got a suspension, which is a mixture of solid floating in a liquid, which has to do with a very important property that we'll discuss in detail, which is density. Right, okay. Now, having said that, we get a sense in terms of classification of matter, in terms of pure and impure substances, your elements and compound being variations of pure substances, while in terms of impure, we've got mixtures, which have got two categories, which is the heterogeneous as well as the homogeneous. And we've managed to look at one at a time, the properties of each of those types of mixtures. For now, let's take a short breather, and then we continue discussing our, very interesting, aspects of classification of matter. Let's take a short break for now. Welcome back to our second segment. We're still looking at classification of matter, but now we want to shift gears and look into the composition of matter. Exactly what is it that makes up matter, so that we get an understanding in terms of the physical properties that make up different materials. Right. Now, so our focus for now will be on the composition of matter. What exactly makes up matter? So we are aware that matter can either be pure substances, in the form of pure substances, or impure substances, right? Okay. Having said that, these are the keywords that will also form part of our discussion. Microscopic particles, which is usually the physical properties, which has to do with how a material, displays certain, physical characteristics. And then we also look at microscopic particles of matter, which could relate to, the packaging of particles that make up that type of matter. Right. So these are the keywords. Now, we understand that matter is everything, or everything is matter, whichever way you choose to look at it. Okay, so matter is everything that has got mass, okay, as well as it occupies space, right? So anything that's got mass and occupies space is matter. So in other words, we can safely say that matter is indeed everything around us, right? Okay, so matter consists of particles and exists in three distinct forms, which is solid, liquid, or gas. Right. So these are the forms or the states in which matter actually exists. So we are quite privy to that information, and we understand that matter can either be a solid, a liquid, or a gas, or it could be a combination of one of the three forms of matter that we have indicated. Right. And then if we talk about the composition of matter, it's very important that we understand the type of packaging in terms of a particular form of matter. We can talk about a solid, we can talk about a liquid or a gas. Just to bring that into context, let's look at this simulation, which actually shows us the different forms of matter. Now, in this case, we've got a solid as an example, okay? If you look at the particles that make up a solid, they're actually vibrating within fixed position. And these particles are actually closely packed to each other, hence they actually occupy, spaces, but there's still some movement of these particles that is characteristics of any form of matter, okay? Now, let's look at a liquid, for example, okay? What is the difference? What has changed? Yes, there is still some movement, but the extent of movement in a liquid is actually greater, and these particles are actually sliding past each other. Okay, this will, in many ways, determine the properties of different substances under different conditions. Now, let's look at the other form of matter, which is a gas. Now, obviously, with the gases, you can see that the packaging is very loose, and the movement is more, is to a greater extent compared to the other two forms of matter, which is the solid and the liquid. But that's not our main focus here. It's just to understand how these particles, the microscopic view of different forms of matter under different conditions. Right. Let's go back to our discussion. Okay, so the composition is that all matter is made up of particles. Okay, so all matter consists of particles. Okay, that's very important. So if all matter consists of particles, and then we agree that these particles, depending on how they are arranged, it can either be a solid, it could be a liquid, okay? It could also be a gas, all right? So these are the three states or forms of matter. So we'll describe this as the state of matter, or refer to it as states of matter, right? So that's the main point that we're trying to drive home, right? Okay, moving along. So we also have what we call the physical properties. Remember the big questions that we we spoke about to say what exactly informs or influences the choice of use of a particular type of material for a particular purpose in terms of application. That has a lot to do with what we'd refer to as the macroscopic properties, which are the physical properties that makes up that type of material. So we have got, number one, we've got the melting point of a material or a substance, okay? This is the temperature at which a substance changes, okay, from solid to liquid. So the change is actually change of state, okay? But it's still precisely the same substance, okay? And then also, here's a typical example in terms of the differences in terms of physical properties, which is the melting point. If you take, for example, ice, okay, which is water in solid form, right? Okay, it has a melting point of 0 degrees Celsius. Okay, what does that tell us? It tells us that if you've got ice, under normal circumstances, if the temperature is 0 degrees, the ice will start to turn from solid to liquid. That's exactly what we mean when we talk about the melting point, the temperature at which that substance changes its form, okay? So that temperature is 0 degrees, now Celsius. By comparison, the melting point of copper is 1084 degrees Celsius. That's way different, okay, or comparatively greater than that of ice. But there is a reason why these two actually show these differences in terms of the physical properties. We'll look into that into more detail. But the big question is, what does this melting point of a substance tell us about, that particular substance? Water, 0 degrees, copper, 1084 degrees Celsius, okay? Right. And then the boiling point, which is another physical property, okay, of a substance. For now, let's understand boiling point in terms of the temperature at which the liquid changes, to a gas at sea level or standard atmospheric pressure, okay? This is just our understanding in terms of the change of phase or change of state, okay? That's the boiling point. Okay? Now, melting point and boiling point of a substance is a measure of strength or how strong a substance is. So if you are given, a melting point of a substance, that tells us a lot about the strength of that particular substance. So strength is actually a macroscopic property or a physical property of a material, which will also, determine how we use that material in everyday life. So boiling point and melting point, there is an indication of what? Of strength of material, okay? So the strength of material, very important, okay? Right, and then let's also think about thermal conductivity as a typical, physical property, okay? Alongside, we've got, kitchen utensils, which is pots and pans. Now, here's a question, okay? Have you ever thought about why pots and pans are usually made of aluminum? Okay, I'll underline aluminum, while the handles are made of wooden or plastic, okay? Now, this is the big idea that we started with. We are saying that for us to have a particular material being utilized for a particular purpose, it has to speak to its physical properties. There's something special about aluminum in terms of thermal conductivity. What is that exactly? Aluminum transfers heat quite easily, okay? While, plastic and wood, they're quite the opposite. So the physical property that is of interest to us at this point is actually thermal conductivity, because conductivity would vary. We can talk about electrical or thermal. In this case, we're talking about thermal, which has to do with heat energy, okay? Right, so that's the big question. And then it says here, the thermal conductivity is the extent to which a material conducts heat. So thermal conductivity has to do with heat conduction. Now, a good thermal conductor easily transfers heat. Okay, copper is used in plumbing, and it is also corrosion resistant. Okay, we don't use just steel for the plumbing pipes. Copper is corrosion resistant. It means it doesn't rust. Okay, and then a bad thermal conductor is a good insulator. Okay, this is a very important point. If a substance is a good thermal conductor, it means it is a bad insulator. In other words, it depends how you look at it, but we're still saying the same thing. And then a good thermal insulator is actually a bad thermal conductor. Okay, so that's in terms of classification now. And we are talking physical properties, how well these materials transfer heat energy, which actually makes them fit or ideal for specific purposes in everyday life, right? Okay, and then the other thing that that we asked about this, I think we've already answered this to say aluminum is a thermal conductor, while wood and plastic are thermal insulators, right? Okay, now think about another thinking exercise. Think about the material used to make electrical wires, okay? That's its electrification, okay? What type of material is ideal or suitable, okay? And what could be the reason for your choice? Already alongside, we've got, something that we are quite familiar with in our everyday life, which is the copper wire, okay? Now, why is copper ideal for, electrical wires? Okay, that's the big question that we're asking with. Okay, now electrical conductivity is by definition a property that has to do with the material being able to allow electric charge to pass it, which is your electricity. Okay, so copper wires are commonly used in wiring. Why is it so? And also around those copper wires we've got plastic material. Why plastic? Why copper? Okay, the idea is very straightforward. Copper is a good electrical conductor, while plastic is a good electrical insulator. Okay, so that's the main point that we want to actually address. So copper is electric conductor, and then but there's something special about copper. Okay, in some cases we need very thin wires or strands. So any material that can be drawn into fine strands without actually breaking, we say that material is actually ductile. So ductility is a property of a material that allows it to be drawn into fine strands. So it's possible with that. That makes exactly copper to be ideal for this purpose. Okay, so ductile, it means it can be drawn into thin strands or fine wires without it actually breaking. And then we've got electrical insulators that do not conduct electricity, okay? And then plastic is a good insulator, making it actually a bad electrical conductor, if you come to think of it, right? Okay, so having said that, there's also, something that, which we asked ourselves at the beginning to say, by the end of our discussions, at some point or the other, we need to be able to relate the physical property to the use, okay, and vice versa, and to say we can justify why, for example, plastic is used as an insulation, tape in electricity. Why? Because it is a bad electrical conductor, meaning it is a good insulator because it doesn't allow electric charge to pass through it. Okay, we also used an example of the pots and pans in the kitchen. Okay, but if you think of aluminium even deeper, think of it, aluminium is a lighter material. Okay, we're gonna be looking into, in the third and final segment, into a property of density, how heavy, light a given amount of material is. So aluminium is light, it's easy to clean, it is a good thermal conductor, while the handles of the pots are actually made of, plastic or rubber. Why? Because these materials typically they do not allow heat to be transferred through them easily. So it's a combination. So there's a lot of thinking, in terms of observing, what is exactly happening around us to say, okay, the science that we learn actually exists around us. So in the third segment, we shall try and look into, more in terms of classification and, the thinking of in terms of the, the big ideas that we ask. For now, let's take a short breather. Welcome back to our third and final segment. We're still looking at classification of matter, but now we'll turn our attention onto some of the important physical properties of material. But remember, it all has to do with the physical properties so that we use a certain material or substance for a particular application or use. Right. So we're still focusing on physical properties of different materials. Right. Now, in this case, we have a scenario. Okay, we've got two helmets. One is made of plastic, the other one is made of a metal. Okay, now the question is, which helmet would you use for protection? Remember, anything that has got to do with protection relates to safety. Okay, but there are also a number of factors that one has to take into account. What type of material? Should it be comfortable? Should it be heavier? Think about all those brilliant ideas. Now the question is, which helmet would you select for protection? So on the screen you can see we've got two helmets, plastic and metal, right? And then it says here, a solid substance that is hard. So hardness is another physical property, but shatters or cracks when a large force is applied to it will be described as brittle. So materials that are brittle, they actually snap or easily break when you apply a large force at a point on them. So those materials would describe them as brittle. So brittleness has to do with how easily a material snaps when a huge force is applied onto it. Okay, and then a solid substance that changes shape. Okay, when a large force is applied to it is called malleable. Okay, so this property would refer to as malleability. Right? So what exactly are we talking about when we're saying that material is malleable? It means this material can be molded into any shape that we wish to have. So a material that is malleable can be actually shaped into different forms. Okay, think about that as well. Okay, right. And then if you look at the plastic helmet rather, because it is about safety, we are saying that it is slightly brittle. Okay, and then at the same time we are saying that the metal is malleable. Okay, so a metal can be molded into any shape, and then we're also saying that the plastic helmet can easily snap when a large force is actually applied to it at a point. Okay, right. And then the plastic head is used in helmet is not heavy for its size. All right, now this gets us thinking, plastic compared to metal. Ordinarily a plastic material will be comparatively lighter compared to a metal one. Okay, so we onto something here. Think about it now. We spoke about hardness, how easily it snaps when a large force is applied on it. Now we're talking about whether it's heavy or light. Okay, so we are saying the plastic head used in helmet is not as heavy for its size. Okay, but the metal head used to make the helmet is actually heavy for its size. So it's a combination of size as well as mass. So when we talk about heaviness, we're actually talking about mass of a material, right? Okay, and then size, actually we're talking about how much space it occupies, which could relate to actually what we refer to as volume, how much space it occupies. So it's about the size and as well as the mass, right? Okay, so a solid substance that is heavy for its size is a substance with a high density, right? So you have a case whereby the plastic material is lighter for its size, then it means then the density is low. While a metal, which is heavier for its size, its density will be actually high, right? So we're saying that a solid substance that is very heavy for its size or for its material is actually a high density type of a material, right? So, but in essence, what is density as a physical property? Okay, so density of a material is this mass per unit volume. So in other words, we can say density is equals to mass divided by volume. Okay, so we would also put it in this form if we so wish. Okay, density, mass per unit volume, right? So the ratio of mass to volume of a material actually gives us the density of that material. And density appeals a lot, or I think it relates a lot to, you know, the use of a type of material for a particular purpose, because it has to do with mass and how much space it occupies in terms of volume, right? Okay, so in terms of the microscopic view, the packaging of materials, of particles that make up a material or a substance, and the amount of space they occupy determines the density. You can think about, you know, this is a very common example. If you think of a 50 kg of cement and a 50 kg of feathers, in both cases, the mass is 50 kg. But in terms of the space that each one of these materials occupy, the cement will occupy a very small space, you know, in terms of volume. So for its size, then it means it's high density. Because we are saying that density is actually equals to mass, okay, over volume, okay? That's what density is all about. Now, if that's a density, and then we are saying that cement takes a lesser volume for the same mass, it means it will be high density, okay? And then those that occupy more volume would be actually low density, provided the mass is comparable, okay? So we are saying that the ratio of mass per unit volume of a substance is actually the density, and it has a lot to do with how the particles that make up that material are actually packaged, right? Okay, now if you look at the microscopic view at a particle level, you look at, let's say we've got substance A, which it could be plastic, this could be plastic, okay, because we have that background now, and then maybe this could be a metal that was used to make that helmet. You can immediately tell that the particles, you know, at a microscopic level that make up the plastic are loosely packed, you know, so they occupy a greater space compared to those particles that make up a metal, which are closely packed, you know, very tight. As a result, this will be high density and this will be low density. So this metal is actually high density, okay, because it occupies a lesser space, while this one will be a low density, right? Very important, you know, point. Just by comparison, we can immediately arrive at that conclusion. Okay, so if we are saying plastic is low density, it is lighter, it's easy to carry. You know, you can walk around, you know, even in a construction site, because it's about safety. Every time you need to have that. So if it's a low density, it means it will be lighter, and it could be ideal for that purpose of safety. While the high density one becomes even much more heavy by comparison. Okay, so the point is that the metal will actually be a high density, while the plastic is comparatively of lower density. Okay, so the question that we asked ourselves is, which helmet would you select for protection? Okay, it entirely depends. For the fitness of purpose, it means this plastic helmet becomes more ideal. Okay, right. So in summary, what are we saying? After all has been said and done, we've managed to look at the broad categories of what matter is in terms of pure and impure substances, and we further classified that these pure substances can either be elements or compounds. We didn't focus our attention on that for now, but we looked at impure substances in terms of mixtures, you know, homogeneous as well as heterogeneous. So in short, what are the things that we have to take home is that all forms of matter have got mass and volume. Okay, that has got mass and occupies space. That's the volume part of it. So, okay, so we classified matter into pure substances and impure substances, okay, which we refer to as mixtures. And then we looked at mixtures in a bit more detail, where we discussed homogeneous as the uniform mixtures, you know, while the heterogeneous are non-uniform type of impure substances, okay? And then also, we also appreciated the fact that matter consists of particles, and this packaging, which also determined, you know, the density and other physical properties that a particular material has, is very, very important, okay? And then we also agreed that the physical properties of a substance determines how it can be used, you know, as a material. So it is about the physical properties. So at the end of the day, if we get to a point where we say, for this particular purpose, we need this type of material, our choice will be actually influenced or be informed or be determined by the physical properties of that particular material. Having said that, I think it makes a lot of sense because we've gone full circle now, because we've asked ourselves the big question to say, what influences our choice? Now, the answer to that is simply the fact that it has to do with the physical properties of a material. For myself, Themba Ncube, is cheers and bye-bye for now.